This is a 555 timer IC, and this small 8-pin chip is one of the most useful ICs in electronics. It is used to create delay, generate pulses, and produce switching signals in many circuits. In this video, I'm going to explain everything you need to know about the 555 timer IC. First, we will look at what a timer IC is. Second, we will look at how it works. Third, we will explain the pinout. Fourth, we will look at the different modes. Fifth, we will talk about the characteristics. And lastly, I will show you how the 555 timer IC can be used in real electronics projects, including a simple inverter circuit. So stay to the end of this video to understand how this small IC works. And if this video gives you value, please smash the like button and subscribe to this channel. So let's break it down. What is a 55 timer IC? In simple term, a 55 timer IC is an integrated circuit used to create timing delays, pulses, and oscillation in electronic circuits. In other words, it is a small chip that can control time. It can turn something on for a few seconds. It can turn something off after a delay. It can blink an LED continuously. It can generate a fast switching signal, and because of that, it is used in many beginner and professional electronics projects. You can find it in timer circuits, alarm circuits, LED flasher circuits, pulse generator circuits, relay delay circuits, PWM circuits, and simple inverter circuits. The 555 timer became popular because it is cheap, easy to use, and very flexible. This is why many electronics students usually meet this IC very early when learning practical electronics. Why the 555 timer is so important. Now, the reason the 555 timer is powerful is not because it is big. It is powerful because it can replace many small timing circuits. Before you can make a timing circuit, you may need transistors, resistors, capacitors, and other components arranged in a complicated way. But with the 555 timer IC, most of that work is already inside the chip, so instead of building the whole timing circuit from scratch, you can use the 555 timer and just add a few external resistors and capacitors to control how fast or how slow it works. That is why it is useful. With only a few components, you can decide the timing of your circuit. If you want an LED to blink slowly, you can do that. If you want it to blink fast, you can do that too. If you want a relay to turn on after a short delay, the 555 timer can help you do it. And if you want to generate pulses for switching a MOSFET, the 555 timer can also do that. So now let's look at the 8 pins of the 555 timer IC. Pin 1 is ground. This pin is connected to the negative side of the power supply. Without this pin connected properly, the IC will not work. Pin 2 is trigger. This pin is used to start the timing action. When the voltage on this pin drops below a certain level, the 555 timer output changes state. So you can think of pin 2 as the pin that tells the IC, start now. Pin 3 is output. This is where we get the signal from the 555 timer. The output can go high or low. When it is high, it can turn on an LED, drive a transistor, send signal to a MOSFET, or control another circuit. Pin 4 is reset. This pin is used to reset the 555 timer. If this pin is pulled low, the IC stops working and the output goes low. But in many simple circuits, pin 4 is connected to the positive supply, so the IC can work normally. Pin 5 is control voltage. This pin allows you to control the internal reference voltage of the timer. In many beginner circuits, we connect a small capacitor from pin 5 to ground to reduce noise and make the circuit stable. Pin 6 is threshold. This pin monitors the voltage across the timing capacitor. When the capacitor charges to a certain level, the 555 timer changes its output state. Pin 7 is discharge. This pin is connected internally to a transistor inside the IC. It is used to discharge the timing capacitor. This charging and discharging action is one of the main reasons the 555 timer can create delays and pulses. Pin 8 is VCC. This is the positive power supply pin. Depending on the type of 555 timer and the circuit, this pin is connected to the positive voltage supply. So those are the 8 pins: ground, trigger, output, reset, control voltage, threshold, discharge, and VCC. Once you understand these pins, 555 timer circuits become much easier. So now let me explain the working principle in a simple way. The 555 timer works by charging and discharging a capacitor. That capacitor is usually connected outside the IC. When the capacitor is charging, the voltage across it is rising. When it reaches a certain level, the 555 timer changes the output. Then the capacitor starts discharging. When the voltage drops again, the output changes back. This process can happen once, or it can continue again and again. And that is how the 555 timer can create a delay or generate a continuous pulse. The resistors and capacitors connected to the IC decide the timing. So if you change the resistor value, the timing changes. If you change the capacitor value, the timing also changes. That is why in many 555 timer circuits, you will always see resistors and capacitors around the IC. They are not just random components. They are the components that control the time. Now let's talk about the first important mode, Astable mode. In Astable mode, the 555 timer works like an oscillator. That means it keeps switching on and off by itself. You do not need to press a button to trigger it again and again. Once you power the circuit, the output keeps changing from high to low, again and again. This is the mode used for LED flasher circuits. For example, if you connect an LED to the output pin, the LED will blink. If the timing is slow, the LED blinks slowly. If the timing is fast, the LED blinks fast. This same Astable mode can also be used to create a square wave signal, and this is very useful in many electronics projects. For example, in a simple inverter circuit, the 555 timer can be used to generate the switching signal. That signal can then be sent to MOSFETs, and the MOSFETs can switch a transformer. So when you hear 555 timer inverter, most of the time, the 555 timer is being used in Astable mode to create switching pulses. The second important mode is Monostable mode. In Monostable mode, the 555 timer works like a one-shot timer. That means when you trigger it, the output turns on for a certain period of time, and then it turns off automatically. For example, you press a button, the output turns on. Maybe an LED lights up. Maybe a relay turns on. After a few seconds, it turns off by itself. That is Monostable mode. This mode is useful for delay circuits. You can use it for automatic light delay, relay delay, touch switch delay, alarm timing, and many other projects. So the main difference is simple. Astable mode keeps running continuously. Monostable mode runs. The third mode is Bistable mode. In Bistable mode, the 555 timer works like a latch. It has two stable states. The output can stay on until you reset it, or it can stay off until you trigger it. This mode is useful when you want a simple on and off control circuit. For example, one button can turn the output on, and another button can turn it off. It is not as popular as Astable and Monostable mode for beginners, but it is still important to know. Now let's use a 555 timer to design an interesting project, a 12 volt to 220 volt inverter circuit. So basically a 12 volt battery gives DC voltage, but the major electrical component that I use to step up voltage is a transformer. But a transformer cannot step up pure DC properly. A transformer needs a changing signal, which is called alternating current. So we need to switch the 12 volt DC very fast so the transformer can work. This is where the 555 timer comes in. The 555 timer is connected in Astable mode, so it creates continuous pulses, but the 555 timer alone cannot power the transformer directly. The output signal from the 555 timer is small, so we send that signal to power switching components, like MOSFETs. So the MOSFETs act like fast electronic switches. They take the timing signal from the 555 timer and use it to switch current through the transformer winding. Once the transformer receives this changing current, it can step the voltage up. That is how a small 12-volt battery can be used to light a small AC bulb through an inverter circuit. So in simple terms, the battery provides 12 volts DC. The 555 timer creates the switching signal. The MOSFETs switch the transformer. The transformer steps up the voltage, and the bulb lights up. This is not the same as a professional pure sine wave inverter, but it is a very good project for understanding the basic principle of inverter circuits. So now let's talk about some mistakes beginners make with the 555 timer. The first mistake is connecting the IC in the wrong direction. The 555 timer has a notch or dot that indicates the direction of pin 1. If you rotate the IC wrongly, the circuit will not work, and the IC may get damaged. The second mistake is leaving pin 4 floating. Pin 4 is the reset pin. In many simple circuits, it should be connected to the positive supply so the IC can run normally. The third mistake is using the wrong capacitor value. If the capacitor is too small, the timing may be too fast. If it is too big, the timing may be too slow. The fourth mistake is expecting the 555 timer output to power heavy loads directly. The output pin can drive small loads, but for bigger loads like motors, relays, transformers, or high current circuits, you need a transistor or MOSFET. The fifth mistake is not using a stable power supply. If your supply is noisy or weak, the 555 timer may behave strangely. So let's summarize everything. The 555 timer IC is a small 8-pin chip used for timing, delay, pulse generation, and oscillation. It has 3 main modes. Astable mode creates continuous pulses. Monostable mode creates one-timed pulse after triggering. Bistable mode works like an on and off latch. The 555 timer can be used in LED flasher circuits, delay circuits, alarm circuits, relay circuits, PWM circuits, and simple inverter circuits. And in a 12-volt to 220-volt inverter circuit, the 555 timer is used to generate the switching signal, while the MOSFETs handle the power switching, and the transformer steps up the voltage. So if you understand the 555 timer, you are not just learning one IC. You are learning one of the most useful building blocks in electronics. What electronics component should I explain next? Drop it in the comments. And if this video helped you understand the 555 timer, like the video, subscribe and follow for more simple electronics explanations. Peace and love.